I'm thrilled to have you here for yet another exciting edition of Stories Behind Products. I'm Oya Demirbilek, a professor of industrial design at UNSW, and I'm delighted to welcome you all from Istanbul this time in Turkey, the beautiful country where I'm temporarily living and working. So this evening, our presenter is Amy Leedham, an alum of industrial design honors at UNSW. It is so nice to have you here, Amy. So Amy is one.
Great to be here. Thanks.
Amy is one of our outstanding UNSW alums with a first-class honors Bachelor of Industrial Design. She also has a Master's of Interaction Design and Electronic Arts, Human-Computer Interaction from the University of Sydney. And Amy is currently the lead designer at Multigate Medical Products, leading and mentoring a team to design experiences supported by physical and digital products. And back in 2016, Amy received the Graduate of the Year award as one of New South Wales' top designers. And in an interview, she said that this award was encouraging, and especially after just completing her degree. And Amy, you said that it inspired you to move into an industrial design career that allows you to help people, which is exactly what you're doing right now. So Amy will talk about the Cadence Suction Irrigator. This is a surgical device that plays an important role in maintaining a clear surgical site during keyhole surgery. And this product received the Gold Award at the Good Design Awards Australia in 2019. And you can ask your questions to Amy via the chat function, and we will answer them at the end of the presentation. So now it's time for Amy to take the stage. Over to you, Amy. You can start sharing your slides. I'll stop sharing.
Great. Thank you. What an intro. That was lovely. I think I also want to celebrate being the first woman to present in this series. That's really cool. So what an achievement. So as Oya said, I'm the lead designer at Multigate at the moment, and I kind of exist in two different capacities. So we work on physical products with industrial designers, and we also have a team working on our digital experiences with UX design. So I'm really busy, and it was certainly a thing to go back and look at this project that I'm presenting today, because it was one of the first things I ever worked on as a junior designer. So I'm going to share my screen. Let's go. Can everyone see that? Yep. Cool. All right, the Multigate Cadence laparoscopic suction irrigation device. So I should probably start by telling you a bit about Multigate. If you work in the hospital type industry, you would definitely have heard this brand, but if you haven't, it's going to seem a bit unfamiliar. Multigate is a B2B supplier of medical consumables, single use, and specializing in custom procedure packs to support surgeries. We have over 3,000 products. And we're committed to improving the performance of clinicians and advancing the world of hospital care. In 2015, we acquired a company called Eisner, and this company specializes in reusable laparoscopic instruments. And it's an important thing for this project because we were to create a single-use range to complement this. So it's actually a range of products. Cadence is a range. So we have a family of products here. And I was the project lead for the ones in the middle here, the monopolar instruments. And there's some cool stories behind those. But today we're focusing on the laparoscopic suction and irrigation device. This project is really cool. It actually had started before I joined the company. So it takes a team of people to build something like this. And I have to give a special mention to Daniel Max, Shirley Liu, Mark Armstrong, Mark Spale, and Alana Layton as the original team that worked on this project. I joined after it had started. I did a chunk of work on it for sure, as did everyone else who is listed there. I have to let you just be aware that there's going to be some images of blood and surgery, not heaps, but just a little bit. And if you can't handle it, maybe do what you need to do. So how did we start? Multigate wanted to they wanted to enter the laparoscopic single-use market. So this was a new to company type project. And they wanted to do that with a premium product offering that would be differentiated from the rest of what was on offer. In terms of customer insights, we didn't start with a lot. It was also a very young design team, so there wasn't precedence for doing, first-hand research with customers. And this kind of created a storm that was very challenging, and I'm super proud of what we did considering what we were working with. So what is laparoscopic surgery? It's keyhole surgery or minimally invasive surgery. You can see in this little illustration here that it involves pumping the peritoneal cavity up with CO2 gas, not oxygen, because oxygen is flammable, and that's not good. So you have these ports, and there's 3 to 4 ports, and the surgeon works with these really long instruments, and all they can see is whatever's on the camera. So this tiny little window here. One surgeon described this as being like doing a handstand whilst balancing an egg on a teaspoon. Like, it takes a lot of coordination. Yeah, it's real hard. So the existing product is real basic. It looks like a piece of plumbing. And that was one of the first things that stood out to us. I can't believe that this was a surgical device. And how it's used in surgery, it's got a lot of tubing, and there's some standard connectors to an irrigation pole, bag, that's on a pole, and a suction canister. So that's your suction and that's your irrigation. The power of that irrigation is gravity fed. So the higher the pole is, the faster it'll go. But you can only set the pole so high because nurses aren't that tall. Other thing in the market is a pump. So sometimes you can get a pump that you add here and it will kind of push the irrigation out with a bit more force, but they're not super common because of cost and waste, and they kind of make an annoying noise. So right from the beginning, the team had a few questions that we wanted to look into. The first of them was, how can we improve the flow of irrigation without the need for that pump? And the second one was about surgeon comfort. So we had to look into these a bit further. And I'm going to go on 2 tangents here to cover those 2 things and then bring it back together later. So let's just focus on the first one for now. So this was our very first journey map. It was created through conversation with people who had either used the device or had seen it be used. And it was pretty high level, but it helped the team understand that this device plays an important role in cleaning the surgical site so that surgeons can see if there's a bleed. And you need to stop bleeds really quickly in laparoscopic surgery because you don't have immediate access to the peritoneal cavity. And patients can bleed out and die. It's not good. The other thing that it's used for is for very gentle dissection. So you can scrape, it sounds gross, but you can scrape tissue very gently with the end of the shaft. And you can also use the irrigation to kind of push tissue apart. So if we look at what's happening with the irrigation and the suction, we kept hearing surgeons say things like, I want it to come out with some gusto, or I want the saline to come out with some enthusiasm. But when we observed what was happening, it's not just that it's slow, it's also coming out in every direction except for the one you're pointing it in. And that's because it's getting caught on these little apertures here. But those apertures are really important because it also has a suction function, and they get blocked by the tissue whilst you're pulling the fluid out. So this was where we wanted to focus. Suction was fine, but yeah, irrigation not as fine. That's where we focused our effort. So I don't know much about fluid dynamics, but our engineers looked into it, and there's a bunch of existing knowledge about how to manipulate the behavior of fluid, sometimes even increase its velocity. So they looked into that. The analogy that I like, because it's quite relatable, is a garden hose. So you can change the behavior of the flow of fluid through the design of the nozzle. And you can see that on like shower heads and stuff as well, but the garden hose is a good analogy. So this was how we approached it. We created a flow restriction portion in the shaft. And we had two concepts to do this. There was one with an insert and one with a swage type design, which is what we ended up going with. So the theory here, and it's not laminar flow. People get this wrong all the time. It's not laminar flow. It's just this diameter is smaller and the irrigation's got some velocity, some inertia in it. And it kind of skips past the apertures and comes out in a stream. But then the suction still works. So this was the idea. And we patented it, which was a whole bunch of work. My only advice here is don't use photographs in your patents. Do a drawing. And we had to work on manufacturing it. So we told our supplier about this and they're like, okay, yeah, cool. But how? How am I going to do this? So our engineers worked on creating a proof of concept machine to manufacture the swage in the shaft. And they built it, it functioned, we shipped it to China. Our engineer took it over there and kind of told them how it worked. So you'll see in some of our photographs later that the swage doesn't feature in our prototypes because it took a really long time to get right. But yeah, we got there eventually and it was a massive difference. Like, look at that. That's really cool. We went from this like dribbly saline solution thing here to really predictable flow. So that was cool. Okay, let's focus on the second topic here. How do we improve surgeon comfort? If you do a desktop research, you'll kind of see, what they teach surgeons when they're studying. You should keep your shoulders down and your arms straight and have this kind of 120-degree angle to your arms. And there's kind of predictable surgical layouts. But in reality, it's not quite like that. And I know this because we did a bunch of observational research. So that's me in scrubs in an operating theatre. We did quite a few surgery observations. And you can see there the journey that we made is a lot more detailed and nuanced compared to the one we created through just conversations of what people remembered. So that's a handy thing to do for your design team. What we found is that there's infinite variation. So no two operating theatres are the same. No two surgeons do the same surgery the same way. And there's a lot of different types of procedures. So you can't really predict exactly how people are going to be standing. There's also, so we see surgeons standing up with their arms out and often leaning over, and they're sacrificing their health and well-being for the sake of the surgery. Unsurprisingly, there's a lot of musculoskeletal injuries in surgeons due to their profession. And, this was not something that we could ever fix with a single device. Robotic surgery comes close, interestingly, but not everyone can access that. So we did see this as a thing that would be a good thing to address however we could. So if we look at all of our qualitative research findings, there was a big theme on ergonomics. So we're looking at different grip styles to get those different angles and handpiece ergonomics. So not only is this device kind of awkward looking, but the buttons are really hard to press. So you have to use your thumb. There was also something surprising in that the handpiece looks like it's all function, but it actually leaks a lot. We had surgeons describing them as incontinent, which is a very surgeon thing to say. And then we had this other finding, which is that using this device is like wrestling the tail of a dragon. I don't know if you can imagine a garden hose, like imagine doing surgery with that and it constantly pushing back against you. That was something we wanted to try and fix if we could. And the dribbling irrigation thing persisted, so that was a strong theme. Okay, here's some cool sketches. We did brainstorming sessions and the designers, went away and refined things. Our engineers worked on some mechanisms, and we kind of landed in this concept at the bottom here, where we had a dual grip design. And then we worked on refining the handle for different hand sizes. And one of the things we had to address was that these buttons are really close together in our early prototype. So if you have fingers like this person here, you could not physically press that top button without activating the other one. And I'm really glad that we looked at all these different hand sizes to get it right. So we had these kind of notches in the middle to separate them, or we looked at, we saw that hands were slipping off. So we kind of had a notch at the bottom, which is what we've ended up with here. We also had a color change. So this was driven mostly by a brand update. So Multigate's old brand color used to be this blue. And then in the middle of this project, it changed and suddenly it was teal. So we had to adapt. But this was our concept for solving the comfort problem. We had a pistol grip and a trumpet grip with these really comfortable button and grip and hand designs. And then we needed to solve the leaking problem. So we very ambitiously pursued something called a pinch valve. And look, there's some good logic to this. So this can't leak unless the tubing physically breaks or if one of these attachment points fail. And they're not moving, so it's a pretty reliable way to seal something so that it doesn't leak. But we had some conflicting requirements here. We needed the buttons to be easy enough to press so that you're not causing injury to the surgeon. But you also need that spring to be strong enough to crush this tubing here and seal it off. So all the senior designers and engineers are going to be like, that's a bit of a conflicting requirement there, probably not good. And we knew that and we did it anyway. And it was really, really hard to get right. So I'd recommend not doing that if you find that in your project. So wrestling the tail of a dragon issue, we had this idea to have softer tubing coming out for a portion of the tubing length. And the idea was that you'd fix that tubing somewhere, anchor it, and then when you move your hand around, there would be less resistance. So we're feeling really good about our concept here. We went from like a leaky plumbing device with dribbly saline to a really comfortable leak-free device with dual grip and performance flow. So we made an appearance model. So these were either 3D printed or CNC milled and spray painted. And we went out and we did desktop evaluations with surgeons. And these were some of the things they said. So they were generally really positive about the device being very comfortable, the dual grip's good, the colors are good, buttons are good. But they did say that the buttons feel a bit too close together, but they can get used to it. And this sort of thing happens a lot in product development. It's not that they're too close together and you can't use it. It's just that they're closer together than the thing they're used to using. That's not necessarily a bad thing. But what we heard for the tubing idea wasn't really working out. They actually perceived it as being heavier because it was softer and it was dragging down more than the other one. So this is where we're at. We're winning in some ways and not in the other way. And kind of in the background, we were doing some testing as well on that tubing. And awkwardly, we found that it actually fails functionally. So if you submit it to -60 kPa, suction pressure, it actually collapses, and it is prone to kinking as well. So we had to rapidly redesign this part of the handle. We extended the PVC tubing down, designed a new spigot, which we thought at one point wouldn't fit in the handle, but it did. So that's good. We had to source new tubing that wouldn't collapse for the internal mechanism, and then make the buttons stronger. So there we go. This is the concept after some roundabout design work, and we needed to now manufacture it. So we're only halfway. So design for manufacture is a lot more than draft angles, although that is a good thing. It's also about like production efficiencies and assembly processes. And we found that even though our engineers were putting a lot of effort into making the parts great for manufacture and ready, our suppliers were further refining them and changing them for various very relevant reasons. So my advice would be just get it close enough and work with your manufacturers to refine it to where it needs to be. So this, for example, is a detail that's used for ultrasonic welding. So to weld these two parts together, you have this kind of rib here. That's the bit that contacts the other part. And with the ultrasonic welding, it kind of melts and fills this gap and kind of bonds the two bits together. Yeah, if you just make it roughly look like that, they'll figure the rest out. It's good enough. We had heaps of files and revision management to do. So we had 44 CAD files to maintain in SolidWorks and step format because the factory couldn't open SolidWorks files. We had the drawing files in DWG and PDF. We also had a bill of materials to maintain for 4 SKUs. So the device came in a few different variants that we had to manage. And there were 11 rounds of revision to get all of the things right. There's a lot of work. And this doesn't even include the packaging, which was a whole extra thing again. But fun fact, the mold texture that we use on our device is the MT11003, which is the satin of mold textures. I think it's a really nice texture. Okay, supplier communication. I don't speak Chinese, by the way. There was a lot of Google Translate in this project. But I can tell you kind of what's happening here. We used PowerPoint extensively. So this comment here is about the plug here not being molded properly. It had like wrinkles on it. It wasn't quite good. And this one here is about the pigment. So this white and this white were different. And this one is about the mixing of the pigment and the pigment color of the gray button. So my tip here is to color code the answers that each party gives so that you can keep track of everything. You will have potentially, at least we did, many of these PowerPoint files, and they all have many pages. So that helps you keep track of it. Okay, big breath. Medical device design controls is the regulatory red tape that keeps people safe, but it's a lot of work. And that's the standard, that's the clause if you want to go find it. I think you have to pay for it, actually. Anyway, these are the things that it covers. And it's basically just a mountain load of documentation, all to keep patients safe. So instead of boring you with all the details, I'm going to give you a really quick example of just a little bit of it so you can get an idea. So one of the risks that we identified for the project was loose objects can get left inside the patient after surgery if they're not part of the standard surgical count. So that's the standard surgical count is things like swabs and sutures and blades. So there was a recent example this year where a poor woman gave birth via cesarean section, and a device called an Alexis wound retractor was left inside her. It's quite large. It's like the size of a small dinner plate. A baby can fit through it. It was left inside her abdomen for 18 months. And they didn't find it because it didn't show up on X-ray. It wasn't X-ray detectable. So that's a really awful thing to happen to anyone. So this was our input then. The loose cap down there on the bottom of our device had to be X-ray detectable. So the output here is a specification for the material. We included a certain percentage of barium sulfate in the polymer mix, which is a X-ray detectable compound. And we have a strong history of doing this with other products. So there was a precedence there. We didn't actually have to test it, but we did anyway. And there's an X-ray. It's not inside a real patient. I showed this to one of my colleagues this morning and she freaked out. It's not inside a real patient. No one was hurt, I promise. But it is there. You can kind of see it on the X-ray. And that's a really cool thing you would never have known if I didn't tell you about it. Lots of work goes into making products safe for people. Part of our testing process also highlighted another major failure. So we had to age test our products. Single-use medical consumables are perishables, effectively. So after simulating a 3-year shelf life, the tubing stuck together. And this is a critical failure. It didn't recover, it didn't open. Basically, you just couldn't use the device. So we had to rapidly design this strap that would go around the housing and keep the buttons depressed while it was in storage. So that resolved the issue. And then skipping ahead a whole bunch, the last 5% of every project always seems to go for 1 million years. And it's a lot of work, but we eventually got there. I'm not going to cover the packaging process in this talk, but there it is. There was also instructions for use and that kind of thing. There we go. There's a device that was ready for use in the market. It was very nice. And here's some of the first photographs from the early trials that we did in surgery. And then in 2019, we got an award, which was really cool. And as part of that submission, we created a video, and I'm going to play it for you so you can see it in action.
The Multigate Cadence Suction Irrigation device is a single-use instrument designed specifically to cater to the needs of the surgeon, the surgical team and the patient. Operating theatres is a fast-paced, stressful and tiring environment. Suction irrigation is central to the maintenance of a clear surgical site. Cadence is the product of countless hours spent in operating theatres with laparoscopic surgeons. Through interviews, observations and clinical evaluations, we observe the struggles that surgeons have in a technically challenging and fast-paced environment. It's an environment where the performance of the instrument has an impact on the procedural flow and the well-being and recovery time of the patient.
My name is Ken Wong. I've been a surgeon for about 12 years. I've been a doctor for about 20 years. Most of my surgery is keyhole surgery, minimally invasive surgery. Often my operating days start at 8 a.m, we finish at 8 p.m. 12 hours we stand around, we do physical manual labour. Every little bit counts. When the instruments are not right, it is a disaster. When the instruments are heavy, hard to use, it creates extra stresses in my operating day. Every extra stress is all very cumulative. At the end of the day, you feel shattered, basically. And that's not good for patient care. Every improvement in design helps. You know, when I don't have to worry about the instrument, when the instrument does what it's meant to do, there's no breakdown, it's easy to use, easy to maneuver, and that's, you know, all I can hope for.
The life of a surgeon is very demanding. They work long hours and routinely put their bodies in uncomfortable positions for long periods of time, and all in the interest of their patients. Our goal for Cadence was to design an instrument that enhances their surgical flow, one that provides effortless precision, superior ergonomics, comfort, so that they can always perform at their best. To enhance precision and control, we simplified the internal mechanism to reduce frustrating leaks. We used more flexible tubing, and that improves manoeuvrability. And we developed a precision tip, which provides constant, precise irrigation and strong suction. To address the issue of surgeon fatigue, we designed an ergonomic and comfortable handpiece. With intuitive buttons, they're easy to depress and very responsive. It gives surgeons the ability to swap between pistol grip and trumpet grip so that they can maintain a more effective neutral body alignment.
Ergonomics is a very important issue in surgery. So I've found that the old reusable instruments, which are often made of heavy metal, which they had needed to be, much more heavier and clunkier. And often over time, just like any metal, they tend to sort of erode or else their function declines. Whereas with disposable instrument, I believe that there's actually cost savings, but actually you always get a clean, feels like a new car feel to them all the time, and you find it easier to use. And I like the Multigate suction device a lot because it's easy to use, it's intuitive, it feels right to the hand. The buttons are very nicely positioned, they've got different depths here. So again, when I put my fingers on, I immediately know, I get a tactile feedback to know which is the suction, which is the irrigation. I like this tip on this suction device because it's quite fine, it's quite maneuverable, it's got multiple channels, so it actually provides good suction. I also like the fact that you've got two choices of grip. The trumpet grip and the pistol grip is useful to have that facility because in many other suction devices I've used, there's no option. You know, if you don't like it, tough luck.
We knew that if we could make Cadence a natural extension of the surgeon's hand, we could help them enhance the flow of procedures, reduce the impact on their body, and ultimately improve the recovery times and outcomes for their patients. We believe we've achieved these goals in our Cadence Suction Irrigation device.
All good, all done, all finished.
There you go. That's my presentation.
Amazing. It's such a great video. And Amy, this is such a great story full of lessons demonstrating the power of a solid design process, time on your hands, good and thorough design research methods like the observation you did, ergonomics, teamwork, collaboration, good documentation, and lots of revisions, communications, and translations along the way because things are manufactured in different countries. I love the part about the X-rayable materials. Who would have thought?
Yeah.
And the result, is a great product that is easy to use and maneuver, and you could hear it from the surgeon's, mouth himself. And it impacts lives positively for surgeons and their patients. So well done. So Amy, we have time for questions. And I think I already had 2 comments. Let's see if there are questions already. Please ask your questions via the chat. I'll read them to Amy. So first is Josh. Josh Flowers says, congrats on an amazing and important design project. Love the detail of including barium in the cap. And the question is, what kind of design challenges would you like to work on in the future?
What an open-ended question. That's really tricky. One of the things I'm really looking forward to doing at Multigate right now and into the future is working on services. So I'm really interested in how quickly digital products can reach such a wide range of people and have such a scalable impact. So yeah, I don't know if that answers your question.
I'm sure it does. The next, it's a comment, it's not a question, it's from Bryce Beard, and he says, amazing presentation, Amy, well done, very insightful. Great to see how HCD methodology was used to deliver valuable and impactful outcomes. I have a question. Yes, I have a question. So my question would be, this is commercial already, the product, I'm assuming. So would you know which hospitals have started using it?
Oh, I actually don't have data on that. Okay. It is being sold. Fun fact though, a lot of designers think that if you design a really good product, people will come and just buy it. You know, like that's good enough. But that's not true. You need, so this was a new to company product for us, and it took the company a while to realize that we needed to hire a dedicated sales team for it. And so we hired that a few years ago, and after we did, sales increased, like they more than doubled when that happened. Like you do need good salespeople. Yeah.
Yeah, marketing is very important. So another question, yes, Anahita is asking, the breadth and depth of this project is so impressive. So proud of you, she says. Can you talk about some of the challenges you had with the research phase of the project?
You asked the good ones, didn't you? Look, doing research in the medical space is really hard. This is an environment that no one has any prior experience with. Surgery happens behind locked and guarded doors, and it is really hard to get out there. So we had to build relationships, and it's still something that we work very hard on. Yeah, it's the kind of thing where you say, oh, I'm not going to get too worried about getting the perfect sample size. I'm just going to try and get as much as I can.
Yeah, I have maybe something related to Anahita's question. I was wondering how you got in the operation rooms, because sometimes some of our students may have projects with hospitals. It's very hard to get permission to get in.
Yeah.
So, but you were doing a project for them. So at the beginning, who initiated that project? Maybe I've missed that part when you mentioned that.
Yeah. So we were instructed to do this by senior management at Multigate. It wasn't a customer request, it was a business decision.
Okay.
Yeah, and I think to get out there, it helps if you're already selling product, because then you're an existing supplier and you can contact your existing customers. But for us, this was a new product for the company, and it was really hard to get those contacts. Yeah,
I can imagine. And you have another comment from Sonia Alam, and she says, I absolutely loved seeing all the info, your hard work and amazing delivery on all the information, wonderful content.
Thanks, Sonia.
Yes, and yes, I think there's no more questions so far. So thank you, Amy, for this excellent presentation and for sharing your story. It was a pleasure to have you here today. And I also want to express my gratitude to everyone who attended this evening, because you helped making it even more unforgettable. And finally, stay tuned for the invitation to our next edition of Stories Behind Products. Until then, stay safe and well, and goodbye, everyone. And thanks again, Amy.
See ya. Bye.
Thank you, Amy.
Bye, everyone.